Hello and welcome everybody to the course Crystal Engineering Chemistry Beyond the Molecule. Halogens play a very important role in crystal engineering. We talk about halogen bonding acceptor, halogen bonding donors, and I have shown you some nice examples, impressive examples, where you can use halogen like iodine and bromine and chlorine to build up, to construct desired crystal structures. And always talking about halogen bonding, I exclude fluorine. I've shown you that fluorine, has no significant sigma hole and is not useful really in halogen bonding. Well, the question is now, can you use fluorine in crystal engineering, or is only not useful in halogen bonding? And well, this is the topic of this video. The role of fluorine in crystal engineering. So in general, if you look to CFH intermolecular interaction, you will see such unit as more in hydrogen bond than in halogen bonding. And if you look in the periodic table, well, you know that fluorine is the most electronegative element. And well, in the first moment you would expect that hydrogen bond with fluorine is a better acceptor than oxygen or nitrogen. You would expect that such units are really useful hydrogen bonds. And well, in one of the first slides, you remember I have shown you with the strongest hydrogen bond isn't exactly with anion of 2 fluorine atoms and 1 hydrogen, extremely high energy. But in the case of organic fluorinated compounds, so organic compounds with fluor substituents, well, then we will see that such units show an extremely low energy value, around about 1 kilojoule. And for example, this is below the Boltzmann energy, which is around about 2.5 kilojoule. So you directly see from the energy, and the energy always is interesting. Yes, energy is always interesting in crystal engineering. Yes, you need units with a minus level of energy to use this in crystal engineering. You can see, there's no significant CFH intermolecular interaction. And they are not similar, like the well-known forming both CO and CN. For example, here there's a very nice contribution from Steiner, Thomas Steiner. Here is at the top you see this kilocalorie, not joule, kilojoule, the energy on the top, and going on. Here, well, where is the energy in the fluorinated compound? And you remember this slide I have shown you talking about calculations. You remember? I've shown you this was an investigation of fluoro-substituted pyridines. And I've shown you very nicely, for example, with FF intermolecular interaction has a positive value, which means, so first of all, there's no significant energetically contribution, and you can see this is repulsive not attractive, it is repulsive forces. Okay, now it's coming, but you can use it. Not in the way of halogen bonding, but one example I've shown you very nicely is if fluorine substituents are present, they have an impact of the acidity of the H atoms. I have shown you this slide talking about hydrogen bonding and talking about weak intermolecular interaction. Yes, this was here benzene, electrostatic potential map of benzene, and in contrast here of pentafluorobenzene. Yes, you see a nicely electrostatic potential map, in this case with really big difference here on this point, this issue, CH. And I have shown you very nicely how you can use such components to design crystal structure. This is the first, A. The second is if no strong intermolecular interactions are present, no strong hydrogen bonds, for example, no strong halogen bonding, for example, no strong PP intermolecular interaction, then you will see with such weak interaction, if you look to the motive for crystal structure, you will see with the topology of this motive could be similar to well-known interaction motive with strong intermolecular interaction. For example, trifluoropyridine, always very, very weak intermolecular interaction. Nothing else, only weak intermolecular interaction. And look here to the crystal packings of trifluorobenzene and triazine. You see the same similar packing. So, in summary, key message is, go home message, no, fluorine elements or the fluorine atoms are not useful in halogen bonding, but they have a secondary effect, could have a secondary effect, can increase acidity using in hydrogen bond, and if no presence, no intermolecular interaction, strong intermolecular interaction, then you will see a similarity of the packing motives. That's it.